project 102 here, and we're going to look at another one of these malware samples that came from the textbook author. So first we're going to use bin text, which we used before, to look at the strings in Lab 0102. So it's bin text, and I browse, and if you're using the machine I pre-made, the malware samples are on the desktop. In this machine, I put them in the downloads folder, and so it's Chapter 1, Lab 0102 is here. All right, so I go, and there are the strings. So you notice, by the way, if you remember last time, there were a lot more strings at the sample we looked at last week. There's very few strings here. And there's even this kind of strange thing where something is broken. This looks like the start of a URL, but it's broken. And what's going on here is this is packed code. All you're seeing here is the unpacker and fragments of strings from the thing that's compressed there. So we need to unpack this code. All right, so what we're going to do is look at PEID. I remember we said PEID helps you find out what language something is written in and helps you identify things like packers. So if I open that same sample here, Lab 0102, it tells me nothing found, okay, which is strange. It would have told me that was C++, but if you look at the sections, it's UPX1. If you look at all the sections, these sections ought to be named like .text and .data and .rdata, but they're named UPX0, 1, and 2, and that is a clue that it's used the UPX packer, which is a open source common packer to pack executables. And you can also see it if you look in PE View and open Lab 0102, which is downloads. Here's my samples. All right, here you see again, UPX 0, 1, and 2 are the names of the headers, and makes it kind of obvious. And if you look at the import directories here, let's see if I can get there. The import directories are down here. Here's the import directory, and notice it only uses a few dills, only 4 dills, which is not very much at all, because all you're seeing is the unpacker. The actual program is hidden inside there. So I'd like to get back to the browser. All right, so we can also look at it with CFF Explorer, which is another fun program. I may not have it in this machine. No, I haven't installed it yet, so I'm not going to demonstrate this one. But anyway, we'll use it in some of the later projects. It's another tool that lets you see inside there, and you'll be able to see the exact functions that it's using from each of those libraries, and it's not very many functions. So now we're going to unpack it with UPX. And UPX, I may have to install it. Let me open a command prompt here and see if I've already got it in C tools, which is where I like to put things. I do have a tools directory, and there's some stuff here, but I don't have UPX, so I'll install it. It's here. All the tools are free. I have to install them because I'm running on ARM, so I can't use the pre-made machine. So there's the Windows 32, Windows 64 version would probably be the best. Oh, there they are. AMD 64, ARM 64, Linux. Here's Win64. Okay, that will probably work. Let's try that. Okay. So let's unzip it. Right-click, extract all, extract. Okay, and that gives me a folder, and in there I've got upx.exe and a few other things, and I just want to put them all in C tools, which is where I like to install things on this machine. So I'm going to just copy all these things and put them all in that directory. There. All right. Now I should be able to run them from my command prompt, which is here. If I do a directory, I now have UPX, so I should be able to run it, UPX, and there it is with a help file. So now I want to put the malware sample in this same directory. This is the part where most students get confused because they don't understand how directories work. Maybe I'll do it the other way. C tools is where the UPX thing is. Now to get to the directory where the malware is, it's quite a drag. I have to go back to users, and then I think I'm named student. Let's see. Yeah, I'm named student. Now I have to go to downloads, and now go into practical malware analysis labs, and do a directory. And again, it's the same thing, practical malware analysis labs, and it's called binary. So these paths get long and people get confused. And then I have to go into lab, do a directory to see what's in here, and it's chapter 1L. So tab will keep incrementing this name there, chapter 1L. Now I can do a directory, and here's my samples. Now I have to run UPX, which is in a different folder. So if you want to run a program from the command line, you have to give it the full path, which is C:/tools/UPX. All right, so I can run UPX from a different directory like this way, and now it's, if I get to my instructions, which are gone. Here, okay. Got to get rid of this. There. So my instructions are get in there and run D. I want to output to unpacked. So there's the command I want. Let me get back to my command prompt. Okay. So now I'm going to run UPX. By the way, I might be able to run it without specifying the full path if it's in the path, which it's not. So I'm just going to do C tools UPX -D to decompress, and put the output in lab 010102 unpacked.exe, and feed in lab 0102 there. So this is going to take lab 0102.exe, which is compressed, decompress it, and put it in this name unpacked. And there's it worked. So it took something that was 3,000 bytes and turned it into something that was 16,000 bytes. So if I do a directory, it's here. So now the unpacked file is going to be have a lot more information in it. So I can start with PEID. On the unpacked file. And now it's in Microsoft Visual C++. And now it has the usual segments, text, RData, and data. So this is a proper Windows executable now that I've unpacked it. And that means I could use PE View, and I would again see the normal sections, and CFF Explorer would show me the normal sections, and the strings will now be much more meaningful. If I use the strings on the unpacked file, I'll browse and go to the unpacked file and go. And now there's a lot more strings. You can see libraries here, a bunch of Windows API calls, wait for single object, create mutex. Here's more Windows function calls. And you'll see down here the usual kind of things. Here's a URL, and here's a name of something it's going to create, and name of, so an Internet Open URL. This apparently does network traffic. So, you can see much more of what it's doing there. And there's another sample here where you can just specify the name of the packer. It's different than UPX. So that's the first thing. And I think the next thing I wanted to show you was manually unpacking, and that'll be the last demo today. I think I'll let the rest wait till next time. But this is interesting. Suppose you have something packed and you don't have the unpacker like UPX. You can still unpack it by using a debugger, which is what we're going to do here. So I've downloaded PuTTY, all right, and now I want to see if I can run it. Sometimes when you download things, Windows will block it. So let's see if it'll run or if it's going to pop up an irritating message. Okay, it popped up an irritating message. I can click More Info and run anyway. All right, and now it runs PuTTY. All right, so PuTTY's just a way to connect to servers, which I don't care about. Now I'm going to check the hash. This is a good thing to do. Run PowerShell. Okay, and never use this ISE. It doesn't work. A lot of Microsoft things don't work. It's the normal command prompt that works. Okay, here we are. Now I want to go to my downloads folder. Okay, and oops, it was so slow. All right, then do a directory, and there should be putty in there. And there it is, putty.exe. So I can get file hash. Okay, algorithm. I think MD5 is what we want. And the file is putty. There. All right, so the MD5 starts with BA7. And that's what it should, BA7. That proves I got the exact file. And you got to have the exact file for this project to work and give the flag you expect. So I'm going to compress the file with UPX. So on my system, I haven't added UPX to the path, so I have to run it with C:\tools, which isn't too bad to UPX. Now to compress it, there's the command I want. Okay, I put the output in puttycomp.exe, and I've got a bad typo there. Okay, puttycomp.exe. That's the output, and the input is putty. I'd like to see if I can get this window to go higher. Okay, putty.exe. That should do it. Putty.exe doesn't exist. No, maybe I got an extra apostrophe at the end. All right. There we go. So putty was 267K, or no, it was 500K, and it shrunk down to 200K. So it made it smaller. All right, now, and we can check the hash of puttycomp. It should be right, starting with 31. Let's try that. Get file hash, algorithm MD5, puttycomp. Invalid arguments. Oh, yeah, the algorithm. Okay, because it's so slow, I have to press tab and wait for it to finish spelling out algorithm. Oh, it's dash algorithm, that's why. Dash algorithm. Tab will finish it. Now MD5. All right, there we go. AF0. That's disturbing. My hash value may be different. Okay, good, I warned you there. I guess the compression isn't always the same. Anyway, now the one interesting thing about this, which is important to understand how this works, is if you go to the folder, downloads here, if you find puttycomp, and let's see if there's some way to get this thing to sort by name or something. There, here's puttycomp. Now notice, it is much smaller. It's 200K instead of 500K. And yet if you run it, it runs just the same. It loads right up. So this unpacker will unpack compressed executables and turn them into RAM issues. All right. Anyway, all right. So that's how it works. Now let me get back to my instructions here. All right, so we're going to use PE Studio. Let's see if I already have it. I don't. All right, I've got to download it. All right. All right. Now I got to unzip it. All right. There it is. And as usual, I want to put it in C tools. So let me do that. And by the way, for a graphical tool like this, it's good to add it to the start menu. So I'll show you that. You know, I take PE Studio and the DIL file, which is probably part of it, and maybe that XML too. I'll just take everything and put it in this folder. And now I take the executable and I right-click, and I want to add to start menu, which they've hidden somewhere, of course. Well, this is Windows 11. I used to be able to add things to the start menu, but Microsoft always hides everything. Right-click, pin to start. There it is. Okay, good. Now I can launch it just from here, PE Studio. And here it is. Now that's the installer. I don't want that. This is the actual program. So PE Studio gives you a lot of information about an executable file. And let me get to my instructions again. All right, let's get rid of this. and get back to this one. All right. So PE Studio, I want to look at both of these things in PE Studio and compare them. So I'm going to open PuTTY. All right. And now while that's running, I'm going to get another copy of PE Studio running and open PuTTY Comp, and we'll be able to compare them. Okay. See if I make a window bigger. Oh, good, that works. All right, so here's the first one, the uncompressed PuTTY, and I don't know why this won't come to the front, and that won't come to the front. Some weird thing is popping up. All right. Alt-Tab. Alt-Tab works. All right, I can move around that way. All right, let me just open the instructions on this other machine because my desktop is too small and somehow I'm not able to. Here it is. All right. All right. That tiny little desktop, I can't see what I'm doing well enough. So let me go here and get the projects open on a different screen. Okay, this is unpacking. All right. So this thing won't move because this mouse is messed up. All right, there we are. All right. So in putty.exe, which is this one, that's PuTTY Comp. This one is putty.exe. All right, so we can find the sections, which should be somewhere over here, directories, sections, there they are. So here's the sections, text, rdata, data, and section 3 called resource. So those are the usual sections you'll see. All right, and if you compare the size, there's the raw size here and the virtual size. And you'll see they're very much the same. 376,000 bytes, 376, 122, 119, 8192. This one's a little bigger, data. But this one is 12. They're pretty much the same in the original file and in memory, because a normal file is not compressed. It just has sections and you just copy them up into memory one by one. But the compressed version of this, the sections are different. You'll see here, the raw size is 0, but the virtual size is 294K. So that's really strange. This one, the raw size is 250 and the RAM size is this. This one matches, and there is no fourth section. So what's going on here is, this is the important data. This is for the program, and it was compressed in one of these other sections, and it was unzipped into RAM. So the section has 0 size on a disk, but it's big in the RAM. All right, and then we can look at permissions. And the permissions are down here. So write, execute, and self-modifying and such. Let's start with the original PuTTY, which is a normal program. For a normal program, you have a text section which is executable but not writable. The rule in Windows and all modern operating systems is write or execute. No section should ever be allowed to be writable and executable at the same time. And this is the correct way for it to be. Execute for the text section and write for the data section where you're going to put in data, but you can't execute there. If we look at the this one, it's got write and execute for several of these sections. And that's why it's turning red and telling you this is a self-modifying program, which is a danger sign. It's not a thing you might, that's why some antivirus engines will flag things just for being compressed, because they look funny. All right, and the other thing to check is the entropy. The text section here, if I go back to the one that has a visible text section, entropy is here, 6.67. Entropy is a measure of how random the bytes are, and assembly code is very random. So complete randomness would be 8. 6.7 is pretty close to randomness. So that's a measure that's typical for a text section. And you can see our data section is like that. The data section is much less random because it probably includes like readable text or something, which is not that random because the letters don't use the entire available 256 bytes. All right, those are a few things to notice about it. All right, and now we can look at the imports. So looking at putty.exe, that's this one. The imports are here. And you just get a feeling there's a lot of API calls here. And just many, many functions are used. And some of them are blacklisted, flagged as dangerous, and some of them even have MITRE functions showing, which I may not see in this version. But anyway, those are the normal imports. And let me compare those to the imports in PuttyComp. All right, so here you see I have many screens of imports in the real Putty. But in PuttyComp, if I go to imports, that's it. It doesn't scroll at all. There's only about 10 or 15 total imports, and that's because what you're seeing is the unpacker. It only uses a few library calls to unpack it, and only when it's unpacked are you going to see it. So, all right, there's some flags here where you find the entry point, and I want to show you Ollie debug. Now, I might have to download it too on this machine. Let's see if I have Ollie. I don't. All right, I'm going to have to get that. So this should be instructions. It is, I think. All right, see if I can get it to stop doing stupid things on my screen. All right, so Ollie debug is down here somewhere. All right, there we are. So I get Ollie debug. This is a famous debugger, easy to use, very popular. The only problem is it only does 32-bit code. And you want Ollie debug 110. Version 2 is not useful. Version 110 is the good one. It's really old, and it was really popular in the days of 32-bit Windows for hackers to cheat at Windows games. And we're going to use it a lot because it's easy to use. The main limitation being you can't debug 64-bit code. All right, so there's all this Ollie stuff. And again, I want to put it in C tools, which is C tools. All right. So I take everything and put it in C tools. And I don't care about the README files. And now I want to take the executable and pin it to the start menu so I can launch it without having to hunt for it. So it's right-click, pin to start. And now I can launch it from this search box here, Ollie. Ollie debug. There we are. This is your best friend. You're going to spend a lot of time using Ollie debug in this class. It's griping about some DIL file. I don't care. All right. Okay. Now, let me make it smaller so it can be projected and recorded well. All right. There we are. And now, okay, let's get Putty in here. So I open my downloads. That's documents. I want downloads. Putty. All right. Okay, and now I want to make the font bigger. This is possible. Options, appearance, fonts, terminal 6, OEM fixed fonts is the first thing, and then change and make it bold, Lucida. Well, the terminal will do, but bigger is what matters. All right, that's OEM fixed font. And now I can right-click in here and say appearance, font all, OEM fixed. All right, now I've got bigger font so we can see what we're doing here. All right, this is the window you're going to get used to. This is the famous debugger window. At the top left, you have executable code, and here's the assembly code and the addresses. Then you have the registers over here, like EAX and EBX and so on. You have the stack on the bottom right, And at the left, bottom left, you have a hex dump of any region of memory you may choose to dump. So this is putty.exe, and it shows that the code is going to start at this address, 4550F0, and it's going to start with a push 60 command, which you see here at 6860 in hex, or perhaps that's 6A60. All right. Now we're going to have another instance of Ollie and open the compressed version of putty. All right, there's another instance of Ollie. And I want to make it smaller again so we can have two of them on the screen at once. And make that bigger if it will let me go. Won't let me go. Okay, I can make it bigger in one dimension. And the other dimension, it won't let me go. Maybe it will after I open the file. Putty comp is here. All right. Yeah, complaining about something, I don't care. Okay, now right-click, Appearance, Fonts All, and OEM Fixed. All right, and I guess I have to readjust the size of the OEM Fixed again. It didn't keep from before, which is annoying, but that's life. OEM Fixed, change, make it bold and big. All right, there. All right, so now that's big. Now I'll try, now it's going to let me make the window bigger. I was thinking about it for a minute. There we go. All right. All right. So if I compare these two, I'd like to make that column wider. There it goes. So notice it has a different starting address, 4860E0 instead of 4550F0. The compressed file starts differently. Notice it has different commands. It starts with push add instead of push 60. And then it has a move instead of a push putty. So this is a different program, and that's to be expected because what you're seeing is the unpacker. Now let's take a look at the memory maps. You can see how these programs use memory. If you click View, Memory, and now again I have to try to make the font bigger. Right-click, Appearance, Font, OEM. There we go, that makes the memory map bigger. All right, so here's the memory map, and you see down here, here's the putty comp. This one's loaded at 400,000, 401, 449, 487, and notice these regions, UPX0, UPX1, and .resource. There's nothing called text and nothing called data because this is not a normal program. Putty is a normal program. If I view the memory, and again I have to do this nonsense, Appearance, Font, OEM, and now make it bigger. All right. You see here it is, putty, 400,000. Here's text, R data, data, and resource. This is normal stuff. That's a normal executable. All right. Now, I can dump the sections. So here, if I dump the text section here to see what a code section looks like, I can right-click and dump. And that will give me a printout. Once again, it defaults to tiny invisible letters just to drive me nuts. Font, OEM fixed font, there we go, but I can make it big. All right, it has an option that says all font, but it lies. It doesn't apply to all. So here you see readable assembly code. That's what you find in here. This is the executable code that's going to do it. All right. Now, let's take a look at, so this is readable executable code. That's what normal code looks like. Here, if we look at the UPX0 section in putty conf and dump that, it's all zeros. Hey, and notice it actually made the font right in this one. That's nice. But anyway, it's all empty. This is where the executable code belongs, and there's nothing in there. We're going to fix that. All right. So now, if you look at the UPX1 section in the compressed file, which is here, UPX1, right-click, dump. Here's a bunch of stuff. Now, this is not real assembly code. See how it's having trouble reading it? AAA, out, question, question, question. It's trying to interpret this as assembly code, but it doesn't make any sense. It's compressed data. It's basically random numbers. And we saw that before. The entropy was like 6.7. So this is essentially a random area, which is normal for compressed data. So now we're going to observe the unpacking stub. I'm going to go back to the main window here in PuTTY compressed, and we're going to unpack this thing manually. Because it's pretty easy to do, because if you think about a self-extracting file, it has an executable, and if you run it, the first thing it's going to do is unpack the stuff inside it. So all you have to do is scroll down until you see the end of this code. So I'm just going to make these windows a little bigger. So we're just going to, this is a crazy idea, we're just going to scroll through these assembly instructions with the down arrow. So here it's doing stuff in assembly. If I just scroll down, I only have to go down a couple of pages before we're going to hit the end of this. And it's going to be really obvious. And there it is. We're going to hit a region of, there it is, we hit a region of just zeros. So look at what happens here. It does just a few pages of instructions, and then it's going to do a jump to 4550F0. And that is going to be the real address of PuTTY starting. So that's what you're going to, so what we're going to do is we want to run it right to this jump command and then stop. That's when it's done unpacking and it's ready to go. So I'm going to put a breakpoint here, and you can do it with the F2 key on the keyboard, or you can do it with some option up here. There's some way to do it up here, debug. Well, I'll use F2 on the keyboard. There is some way to do it in the menu too, but there's F2. It turns red. So now I have a breakpoint there. Now I can run it. You can run it with F9, or you can hit debug, run, and that will run to the breakpoint. So it runs, and now it tells you breakpoint at that address. So I've run the first few pages of code and then stopped. And now I want to take one more step, which is debug step into. Now it takes one more step, and now look what's happened. Now I am at 4550F0, but look at this code. Push 60, push PuTTYCom, call PuTTYCom. Now I've got the same stuff. I should have the same stuff I would have in normal PuTTY, although somehow I'm not seeing it on the left like I should. But anyway, this is real PuTTY now. I've unpacked it. All right, and now we can build an executable from memory, from here, and we're going to use ollie_dump. Now, we have to add ollie_dump to PuTTY, and I'm running out of time to do a live demonstration, so I'm just going to talk about it now, because I've got to solve other problems here. But what you do is you dump it here with this optional plugin called ollie_dump, which you can add to the Packer. Is this 102 I'm talking about? No, 121. That's why I'm not finding it. Okay, 121 is here. All right, so you can dump the unpacked data from Ollie. You go to plugins, ollie_dump, dump debug process, and when you install Ollie, you'll have to install the optional plugin, ollie_dump, and then you can dump it here. You just have to make sure the start address is correct. Start address plus modify has to add up to this address, and it will by default here. 4550F0, it starts at 400 and 550F0. As long as that stuff is right, you can then dump it and save the file, and you'll have an executable file that is unpacked. This is how you can unpack things even if you don't have the packer, because it comes with the unpacker. And this technique works well for PHP malware and a lot of malware I've used. So you'll be able to analyze it and see the strings in it and such. Sometimes you can't run it. In fact, I frequently find that things extracted this way will not actually run, but a lot of it is intact, and you have the strings. So the string, you can often examine get what you need out of it. So let me check for comments in the Twitch. Something about manually adding something. Yes, and some other people are having trouble getting in 126. So I'm going to stop the demos, and I'm going to try and solve these adding problems.